Welcome back. This is episode 3 of our woodworking design project where we're designing a bar cabinet using Fusion 360 and parametric design techniques. In this episode, we're going to go forward from our last episode when we created a drawer box modeling system and add dovetails to the drawer boxes. I'm going to demonstrate two techniques. One would be for half-blind dovetails that are equally spaced, and the other would be for through dovetails that are unequally spaced. So let's get on with it. I'd just like to also say if you could give a reaction to the video, it would help viewership. Give it a thumbs up or thumbs down, subscribe if you like, and feel free to add comments or questions below. Thanks for watching. So let's look at the geometry of the pins and tails for the drawer box manufacturer that I use. I didn't actually pay a lot of attention to this geometry until I started researching for this project. But here it is. I brought in a canvas into Fusion of a corner of one of their drawers. It's a pretty crappy picture, but it is what it is. And I created a set of geometry here based on specs that they gave me when I called and asked them, what's the geometry on your pin and tail setup? So these are obviously half blind. Let me turn on the sketch behind this and you can see the particulars. Since this is a 4-inch tall drawer, I decided to do this one 4 inches tall. This is the one to pay attention to here, this pin. The width of the top of this was given to me as 9/16. The bottom width of the pin is 7/16. They project 3/8 of an inch and they're repeated 1 inch on center. So that's what we got here. The other important attribute here is that the top of the top pin rests a 1/4 of an inch below the top surface of the side of the drawer. So what I did was create some parameters, surprise, to drive this set of geometry here. And here are the parameters. What we're going to do is export that. I've already done that. And we'll import it into a new design and use it there to actually create this sketch and then extrude the features and all that. So let's go there next. Okay, we're back in the Fusion model for the drawer box that we created in the last episode, and we're going to set about putting some pins and tails on the corner joints here. The drawer box manufacturer that I work with talks in terms of imperial measurements, and all the geometry that I've gotten from them is in inches. So let's first change the units used for this design from millimeters to inches. There, we've done that. We can close this. The next thing I want to do is make sure we're working inside the drawer box component rather than the top level component. The reason for that will become obvious in future episodes. So we're going to start putting some sketching over here on the side, but I'm getting kind of tired of looking at that yellow color there. I don't like that. Let me show you how to change the colors that it assigns. So if you right click on one of the components, there's a cycle component color selection down here. That'll change it. That's a little easier on my eyes. I don't know about yours, but I like that a little better. Sometimes these little things can make a lot of difference. Now we're going to be working on the side panel, so I'd like to get that component selected as the one that we're going to work on rather than the whole drawer box. Let's just pick the side panel here. And I like to do this sketching on a construction plane, and let me just create that here. Construct offset plane on there. There we go. Now, some people would say, why do you keep putting construction planes in here when you can do the sketch geometry right on the surface of a surface model? And the answer is because at some point in time you may want to rediscover where the sketch plane was. Sometimes you can do things that cause Fusion to lose the attribute of what plane was used to sketch on, and you need to correct that. It doesn't happen often, but when it does, it can drive you crazy if you don't know what the sketch plane was. So I just prefer to create them and label them so that I know if I have to do that operation, or if I'm doing 3D sketching and want to modify a sketch, I need to know what sketch plane was used to begin that. We'll deal with that a little later on when we start the wiring project for the lighting. So anyway, we've got a sketch plane here. Let's create a sketch on that plane. And I want to pull out or project some of the features. So let's project the side of the drawer box. Let's project the front of the drawer box. And I guess the only thing else we need is that edge right up there. That should do it for projected geometry. Let's see if we turn off all of the components here. What did we get? Well, we can't turn that off. Let's turn off the body. So that's what we got. That's good. So what are we going to do next? We're going to convert this into construction geometry right there. Now I think we've got something we can start sketching pins on. Let's first sketch a pin, and I'm going to do this in a pretty crude manner, so we can demonstrate some of the power of the constraint tools up here. So I'm going to select the line tool, and we'll just start drawing a pin like this. I'm going to do it very crudely, and then we'll use the constraints to clean it up. So one of the first things I want to do with this is to create a construction line, L for line, X for construction, and I want one from the middle of that line to the middle of this line over here. You'll see why in a second. And then I want to use the horizontal vertical constraint to get these two lines aligned. And now I want to put a constraint of perpendicular between here and here. And that ensures with that perpendicular intersection between the center of this line and the center of that line, that will ensure that the angle of these two lines is the same relative to the middle line here. I hope that's clear. So there's our pin detail, but without any dimensions on it. So we previously exported a bunch of parameters from our dovetail geometry model before that we want to bring in here to give dimensions to the pins and spacing and all that. Let's go get those now. Here's our import, my computer, and parameter files. There it is right there. Pintail parameters episode 3. Let's bring those in. Okay. By the way, if there are naming conflicts when you're importing, it won't overwrite the existing parameter with the same name. It'll just give you an error and it will refuse to import. So if you have any conflicts in names and importing onto an existing parameter file, this will protect you from making any serious errors there. So let's just bring those in. There's our pin width at the top, bottom, the spacing, offset, all those things. So let's start using those. So D for dimension, and we're going to dimension this. We know this is the pin bottom, pin width at the bottom. And we know that the other one here is the pin width at the top. There we go. And we know that the distance here, this is the pin length right there. So that's the shape of our pin. We also know that the top corner of this relative to the top surface of the side panel was specified as well, and that is the pin offset. Pin offset from top. There we go. So that's the position. Well, we're close. The back edge of this is coplanar with the front edge of the side panel. So let's make that relationship. We've got a collinear. Let's make that line collinear with that line. Okay, now that's on the edge of the side panel. You can see here when we turn that on. There we go. Now what we want to do is repeat that, and there's a handy tool here called rectilinear pattern. It's under create and it's down here. So let's create a rectilinear pattern, and let's mouse over these features, and we're going to go this direction with it. We don't know how many yet, so let's back out of this for a second. Let me talk about that. Cancel that operation. Let's go back to our parameters. We need to know the pin count, and the pin count is a function of the height of the drawer box. Now I changed the drawer box height here to 6 1/4 inches because my drawer box manufacturer likes to work in whole inches plus 1/4 of an inch. And I'm going to show you how to use a new function here. So there's all kinds of functions that you can apply to formulas here, just kind of like a spreadsheet. And one that I use frequently is called round. So if you start typing the word round, it gives you the opportunity to create a round function. All this does is round down to the nearest whole number. So we're going to round down the drawer height. And we're going to divide it by the pin spacing. So drawer height divided by pin spacing, that'll give 6 and something, 6 1/4. And because of the round function, it'll round it down to 6, or it should. Let's see if that works. So yeah, the result's 6. So that's how many pins. And so if we change the drawer height, the number of pins will scale with that. So let's do this mouse over again and do our rectilinear pattern. We're going to space these 1 inch apart using a parameter. You can space according to the total distance you want to span, but in this case we want to specify the distance between each of the repeats. So that would be spacing, and the quantity here is going to be pin count, and the distance is going to be the pin spacing. And notice it's created the 6 of them, but it's going up instead of down. Sorry for the phone. So we'll just put a minus sign in front of that and it'll go the other direction. How about that? So there's our 6 pins. Now how are we going to turn that into geometry that's actual pins on the end of the side panel? Well, we'll do that with an extrude. But first I think I want to take these and mirror them across to the other end of our side. And to do that we need a mirror line. Let's add that now. I'm going to reopen that, edit sketch again. Let's create a construction line, and we'll pick the middle of that line to the middle of this line. There we go. And now we can mouse over all of these elements, and we're going to say mirror those, and we're going to select this line as our reflection. So there we are. We got the pins on the other end as well. That operation sure cluttered up our drawing here with all kinds of constraints stuff that are part of creating the mirror. And let me just show you a little pro tip. Over here, people don't often realize in the sketch palette thing you can control what you're seeing. So if you want to get rid of all those constraints, just turn them off. If you don't want to see the dimensions, you can turn them off here. You can get rid of your projected geometry as well by clicking on that. So let's just leave it as it is here and finish this sketch. And now we can add those pins to one of the sides. Let's turn our bodies back on here. And what we're going to do at this point is do an extrude. And we can, I believe, we can just mouse over all of these. Is that true? Yeah. And we can hold down the Shift key and mouse over all of these. Is that true? Yeah. And we're going to extrude, not a distance, but we're going to go to the back side of the drawer side there. And it's trying to do a cut operation. We don't want that. We want to join. So the join is a tricky feature. It will join whatever geometry you're creating with whatever component is turned on in the browser that it intersects with. So if we had the front panel turned on, like this, those pins are going to get joined with the front as well as the side. So let's just leave it here, join, and now we have 2 bodies in that component, one with pins and one without. So the next thing we want to do is put the pins on the other body, and we're going to do the same operation. We'll turn that sketch back on. We'll turn this body off. There we go, and turn the other one on. And we're going to do another extrude with a joint. So E for extrude, we'll pick up these same features again. Those, I'm going to hold Shift, and we'll get these as well. Now, another little pro tip here. We are going to go not from the profile plane, but we're going to go from an object. So we're going to extrude from that surface, and we're going to go to another object, which is this surface right here, and we're going to do a join, and we should get the pins on the other side panel as well. So there we are. Let's do some housekeeping. We've got a sketch over here in the side component. Let's label that. This is the pins. We created a construction panel here, and this is for pin construction plane. So there we are. We don't need that on. I don't think we need the sketch on either, but we do want those bodies on for the next operation. The next thing we're going to do is we're going to um, cut the tails in the front and the back. So let's get those turned on, front and back. And you can see at this point, because we're getting flashing there, those pins are inside, they're inside the front and the back, but we need to cut them out. So can you guess what tool we're going to use here? Yeah, let's go back up to the door box top so we can deal with all of the components in it. And let's do a combine operation where we're going to specify the front drawer as the target body, and the tool body is going to be the side, and it's going to be a cut operation, and we're going to keep the tools. So there we are. And we can do the same thing to specify the back as the target body, the side again as the cutting tool. There we go. Let's turn this around. We can do the same thing on this side. Front's the target, the side's the cutting tool. Once more, the back is the target, the side is the cutting tool. So there we are. We've cut the pins and tails, and I think we're pretty good here. We can bring the door bottom back. We don't need to do any join operations or any of that because that's already been done before when we created this rigid group joint up here. Remember doing that? There we are. Okay, one last save operation here, and the next step is I'm going to show you how I would do this with through dovetails that are unevenly spaced, as though you were going to create them in your shop. Stay tuned. Okay, let's move on to creating through dovetails that are unequally spaced. I think what we're going to do here, let's get the data panel open again. There's our drawer box that we saved. Let's do this. Let's create a new design, and we'll work in that because I don't want to mess with what we've created here already. And let's import that by insert into current design. Right-click on it, insert into current design. So there's the model that we created before, brought into a new design. Now, this paperclip here is your indication that this is an imported model. If we were to reopen this model here, the original drawer box, and start making modifications to it and save it, then when we go back to this model that has that imported into it, it would tell you that there is an updated version available and give you the option to update the model that you've imported to the later, newer version if you want. Now, what I want to do here is get the timeline back from our original model, and I don't really want an imported version here. I just want to import it once. I want to break the link so there's no relationship with what we're doing now and the previous version. So we can break that link by right-clicking on the component that was imported and say break link. All right, so we've got the same drawer box, and if we open the plus sign down here, there's all our timeline features as well. So we can modify those at our heart's content. But there's no relationship now between what we're doing here and the drawer box that we originally imported. So I think the first thing I want to do is backtrack and get rid of some of the through dovetails that we created before, and those are all shown down here in the timeline. There's our pin. That's our pin sketch. Let's get that open. So if we right-click on that and say Edit Sketch, yeah, there's all our pins that we created. So we can safely rewind to that point. What is this? Pin construction plane, we don't need that. This is, what is this feature? That's part of the notch stuff that we did. We don't need that either because I don't think on through dovetail fancy shop built drawers you're going to need notches. Maybe you do, but let's take this out. So the easiest thing to do here is right click and say roll history marker here. This is a construction panel that we don't need, so we can go back one step in the timeline, and then we can right click here past the timeline marker and say delete all features after history marker. Okay, so we're back to where we were before we did the dovetails. And let's start here by first creating a, let's close this data panel. We don't want that. Let's save this. And we call this through dovetail box. Save. Now let's put a construction plane on the side here. Offset plane. Click. There it is. And we can sketch on that. So we're going to create a sketch on here. And like we did before, let's pull some of the geometry in. Project. We'll get the side, we'll get the front, and we'll get the top edge of the side. How's that? We probably don't need them all. There we go. Let's turn off the sides and the back and the front and the bottom. There's the construction geometry that we pulled in. Let's convert that to construction geometry. There we go. All right, now through dovetails with unequal spacing and the like, I generally like to start in the center and work out. So let's create a construction line, L, X for construction. Let's pick up the center of the side panel here. There we go. So we got two. I think I want the lower one. I'm going to ignore that round over for now. There it is. And we can come out here. Let's just verify we've got the right one. So we're going to put a dimension on this and just see what it is. It's going to create a driven dimension because it's not going to allow us to change it, but we can at least see what it is. I just want to make sure they are the same. So yeah, those two are the same. We don't need those anymore. We got the right center point. All right. And another handy thing I generally do is put a point, which is a sketch feature, right at the intersection of the front where I'm working on creating pins and the center of the pin line. So let's just put a point there, and then we're going to say this is coincident with that, and it's coincident with this. So it's right there at the intersection of those two lines. You can do that by just putting the pin on there, but it's so hard to tell that you've got an intersection with both of them. I prefer to do it off to the side and then use a constraint to bring it into conformance so I know it's at the intersection of these two lines. All right, now let's start making a pin. Let's do half a pin. I'm going to turn off the construction line. We'll go to the line command, and let's do a line from here down to there and down to what I'll call our origin. So there's half of a pin. Let's make the front part of that coincident with the front of the drawer. We could also put an angle on here, D for dimension, and from here to here. I don't know, I generally work in something like 8 degrees. There we go. And we could dimension this line. Let's do that. D for dimension. How about 8 millimeters? Good. Now let's put a construction line from our pin here, straight out. All I care about is that is horizontal, so we could put a horizontal constraint on. It's probably going to tell us that we don't need to do that because that would over constrain the geometry. So there's half of our pin. Let's do this next. Let's mirror. I'm going to escape out. Let's select our half a pin. I just want the half a pin, not the reflection line. That's okay. So we're going to mirror that, and the mirror line is right here. Okay, and now we can join those two with another line that is not construction from here to here. All right, so we got one pin in the middle of the drawer side, and it's a total of 16 millimeters tall, and it's got an 8-degree incline there. Sometimes this is specified as a ratio of rather than an angle, but I have cutting tools that will cut an 8-degree bevel on the saw for cutting pins and tails. So I generally use that. You know, make it whatever you want. So how do we make more here? Well, there's a couple ways. Of course, we could swipe over this and we could do a rectilinear pattern and come up this way. Now we're going to get 3 pins this way, the original and 2 others that are all going to be the same size. Um, and because we're doing it this way, we won't be able to change their dimensions because it's part of the rectangular pattern. Let's just do it anyway, and we can start putting some dimensions on. Let's see, can we do that? No, what we could do is take this one out. It'll let us do that. We wouldn't be able to do a dimension on this, let's say that line there. Let's try. See, it would overconstrain the sketch because it's part of a mirror or part of our rectilinear pattern thing. So you really can't change the dimensions on things that you pattern that way. You can delete them, but you can't change the dimensions on them. So let's Control Z out of here and get back to where we were originally. Now let me show you the other method where you'll end up being able to change the dimensions of these. So that's the move command. Let's select the pin feature, and we're going to do a move copy now, and it's right here. Move copy, and let's go up with it. Actually, the first, I'm going to cancel out of that. You'll see why here in a second. Let's try it again. Move copy. So if you're going to make a copy of something in a sketch, you have to specify we're going to make a copy first. It won't give you a chance to say, oh, I've moved it, but I really wanted a copy of it. So let's do that. We can move this up here. We can do it again with this. Move, make a copy, move it up here. There we go. Now we've got, let's turn off these constraint things. So we could change this dimension now. Let's just delete it. And we could put a dimension from here to here and say that was 12. And we could here to here and say that was 12. And we could put a dimension from here to here and say that was 20. And we could dimension where this top pin is relative to the top of the drawer and make that 12. There we go. Then if we wanted to reflect these, we could reflect these down to the bottom using our mirror command. So we'll select them, do a mirror. Our mirror line is right here. And there they are at the bottom. Now, because that's a mirror, we're not going to be able to move them around or change dimensions on them. Same kind of restriction goes as this rectilinear pattern thing. The only way you can get these things copied and moved around so you can modify them later in terms of their size and distances and all that is by using the move copy command as your way of creating additional features. So I guess one other thing I'd like to do here, let's get this a little bigger. Let's make this 15. And why don't we make this 10? And this one 10. That looks like something I might make. So let's finish that sketch. We can turn our side panel back on, and we can use the same technique here. E for extrude. Let's get the side turned on because we want to make sure we're doing a join with that. E for extrude. We can pick these features. And we're going to not go to a distance, but we're going to go to the back side of the panel. So to an object, and we're going to select that, and it's going to be a join operation. So there we are. Of course, we can turn that sketch back on. Where is it? It's up here. Yeah, because we were working at the top level here. So we could mirror that sketch onto the back and do the same thing back there, or we could create a completely different set there. Anyway, and of course, we can extrude these. Let's just do that for grins. Let's say we're going to extrude these things here to the opposite side. And we're going to not start from this profile plane, but we're going to start from an object right here. And we're going to go to a different object, which is the back side of this side. And it's going to be a join. So now we've got the same pins on the opposite side. We can turn on our front and our back. Oops, that's the bottom. And if we want to cut the tails into the back, we can do that with the combine command. So modify combine. The target body is the back. The tool body is the side. It's a cut operation. We're going to keep the tool. We can do the same thing on this side. Combine. Target body is the back. The tool body is the side. There we go. And we have our through dovetails that are unequally spaced. I hope that's informative and gives you some idea of the kind of flexibility you've got here. I always try and use the move copy command to duplicate the tail features or pin features and then modify them individually to get whatever kind of shape and distance and all that I want, rather than using the rectilinear or the mirror command. Anyway, I hope that's helpful. So that's the end of our Fusion design section here for this episode. I often get asked, who is it that you use for your drawer box production that you outsource? And I'm going to tag a little thing here on the end if you're interested in knowing who that is and that sort of thing. Stick around if that's not of interest to you. We'll see you on the next episode. Thanks for watching. Leave comments and questions below. So this is the drawer box company that I use. I've got about a 30-year relationship, maybe longer with them now. I don't have any relationship with them financially other than the fact that I give them money because I'm a customer. But it's Western Dovetail. They're down in the Bay Area near north of San Francisco. I like them because you can specify basically anything you want about the drawer box. The grade of the material, all kinds of material options here. They'll custom do stuff too. You know, whether it's finished or not, you can get it assembled or not, all these different options. So you can basically build it to your spec. Why do I do this as opposed to build my own? Well, I do build my own once in a while, but let me show you what this box might cost. So it's got 5/8 inch slides. Let's do, we're going to do this in cherry, and I want the best grade possible, premium. This will have no knots, no sapwood, consistent color. Finish, I want a premium finish, which includes 2 coats of clear finish on all sides, including the front and back. The top edge, I want their standard radius. They can supply the slides. I get a little better pricing from my local distributor, but I am going to tell them I want it notched and drilled. For the Salice Futura undermount slides, the bottom, I'm probably going to end up going with 3/8, but let's do half-inch cherry here. That bottom drawer on that cabinet is probably going to be something like 9 1/4 tall, 27 inches wide, and 15 inches deep. So $250 for a completed drawer box of that size in top grade cherry, finished, assembled. Probably cost another 30 or 40 to get it to me. You know, $300. I'd rather put my time into other things on this particular project, but that's just an example why I outsource for this particular project.